Hello guys, welcome back. Today we are going to solve Geek for Geeks daily problem, that is transform to prime. Question is, given an array of n integers, find the minimum non-negative number to be inserted in array so that sum of all elements of the array becomes prime. Example is, we have an array 2, 4, 6, 8 and 12 and n is length of array. If we check sum, okay, we will just quickly go one by one. So let me just return sum of ARR. If you see, it is 32. So sum is 32. Now we need to identify a upcoming prime number. So why I am saying upcoming, I mean next, because it is asking positive number, non-negative number to be inserted. So if we add 32 plus 5, so expected output is 5, then it is going to be 37, and 37 is prime number. So they want one element. If we add that element in that array, so the sum will be prime. So let's see the approach. First we will check logic. We will write the logic for a prime number. Check prime logic. So what we will do, we will check if number is 0 or 1. If it is 0, then it's definitely not prime, so we will return false. Now the second case will be if number we will iterate from 2, because we already checked 1, so from iterate to 2 square root of number. Now we are taking square root because it is very optimized, but usually in standard practice they teach you like number divided by 2, so go till half, but it is not required. You can just check square root. So for example, if it is 16, so if we just multiply 4 by 4, so it is going to be 16, but if we go 4 by 4 into 5, it is going to be 20. So upcoming numbers, if we want to achieve 16, then numbers after square root will not work, so that's why we are fine with square root. And now once we iterate, what we will do, if number is divisible by I, then return false, that number is not prime. Else what we can do is, else not the else of this if after the entire iteration, so after entire iteration, that is we started from 2 till square root of that number, after that iteration, if it return nothing, then we can say okay, it is not divisible by any number from 2 to the square root, then we can return okay, true, this is prime number. So this is logic for prime. Now the main logic, that is minimum number. So the logic for minimum number is, we can take a variable, that is sum is equal to what, this sum of array. So sum of all the numbers of array, which is coming out to be 32 here in this case. Now we will take another variable, that is counter, and we will initialize it at 0. Then we will run a infinite loop while true. While true, why? Because in while true we will check if counter plus sum is prime, then return counter, and if that is not the case, then we can say counter plus equal to 1. And as this is an infinite loop, because there will be definitely a prime number after that, so we will say okay, fine, let it be, and we will let it run till infinite. So that is what the entire logic is. Let me quickly write the function, that is def is prime. So here self comma number or nm, that is num. Now we will check if nm is equal to 0 or nm is equal to 1. There is a dot after adding this, okay, return false. Now for I in range of what, 2 till skew, okay, we need math dot sqrt of nm. Now let me quickly import math, and I'm just converting it to integer, and to be safe I'll just add 1 till square root. Then if nm mod I is equal to 0, that is it is completely divisible by this number, we can return false, that this is not a prime number. Else please do check that I am writing it outside the for loop, that is after the completion we will return true, that okay this is a prime number. Now I am just writing another variable sum to the main logic, sm equal to sum of arr. Now again our while loop with true, so this is an infinite loop that is going to be run for entire like forever till we kill or we return something. So counter is equal to 0. Now our counter is initialized to 0, and we will check because we have an example where it is already prime, so we can return 0. So we will check if is prime what, our sum plus counter is prime. If it is prime then return counter, else we can do counter plus equal to 1, so increment it by 1, and again check if it is prime or not, again increment out by 1, again if check if it is prime. At the end if we find that okay this is prime, then it will return counter, else it will return this. And actually it is not required, but I'm just writing -1 to be just okay, it is actually not required, but okay fine. Let's check if we have any issues. This prime is not defined because we need to write self dot, because this is now we are dealing with classes, so in class it is self, so as expected our output is uh, matching with expected output. Let's submit it. Great, it worked. Thank you, see you tomorrow, bye.